Bill Luan is a senior program manager in Coral team, where he is responsible for business partnership, customer engagement, sales support, and developer outreach. Bill has been working at Google for 14 years. He was the former developer relations China regional lead for 10 years before joining the Coral team. Bill has been working in high-tech industry in the US for 37 years, including working at Microsoft and Motorola, leading software product development for more than a decade before joining Google in 2008. Bill is a frequent speaker at many technical conferences, including 3 times at Google I/O, having graduated with BSc and MSc degrees from Southern Illinois University at Edwardsville. Bill has been inducted in his alma mater Hall of Fame for his industry contributions. So the floor is yours, Bill.
Oh, thank you very much, Danilo. And I guess I'm just go ahead and start with my presentation. And thank you again for everyone to join. My topic is using Coral for on-device learning innovations. And so let me run my slides. The agenda of my talk basically just 2 parts. Number 1, to align with the topics of our forum here, and as well as the content is on tiny machine learning. And I'm going to introduce very briefly the TensorFlow micro machine learning model framework. And we have a product actually supports that. That is the new Coral DevBot Micro. And I'm going to actually show a little bit of demo of this product and show how a tiny machine learning model can be used on devices. The second part of this conference is concentrated on device learning. It's actually more than just training a model, but see if you can learn something by the machine on the device. And we have a technology to enable to do that. It's called Teachable Machine. We actually have a demo available on our website to enable machine learning on the fly, if you will, right on the device. So I'm going to briefly talk about that and also showing a demo in my past presentations. So 2 parts of this talk. And I think I have 30 minutes or so, I guess, 40 minutes. Hopefully I'm not going to run too much overtime. So let's get started. So tiny machine learning model. The industry has continued to invest in research and in terms of advancing the machine learning model technology. And one area of that is to make it a small and smaller. So from small to tiny, if you will, the machine learning model framework continue to progress to smaller sizes. So as everybody know, one of the most popular machine learning model framework, TensorFlow, for example, started in 2015 and initially running on cloud only and on large servers. And it is very powerful, but it is very high power consumption, require very large memory footprint. So it's typically only used on cloud in the back end. So really doesn't enable any on-device learning and especially tiny machine learning model concept. But then the technology continued, and in 2017, there's a TensorFlow model being developed and released to the market. And it runs on much smaller computers, on single-board computers, and many IoT devices, for example. Compared to TensorFlow, it uses much less power consumption because the machine is smaller. And the key part of it is the memory footprint is much smaller. So instead of gigabyte, terabytes, it only has about 1 byte of memory in terms of what's needed. And the operator's core is only about 300K. And so this really enables machine learning in a much smaller scale in terms of size and memory footprint and on devices. But now a couple of years ago, the technology developed further, and there's a so-called TensorFlow Micro. So that is in line with what everybody in the industry referred to as the tinyML concept. So this actually runs on much smaller form factor in the machines, run on microcontrollers, which I'm going to talk about, one of the product that we make. And it is using, compared to even the so-called less power consumption on TensorFlow-Lite, it even uses much less power. For example, it can run on battery or even solar power. So this is really enable device down to very, very tiny form factors. And it uses much less memory also. The core part only runs about 16 kilobyte of size. And of course, you need a bit more memory for running your applications and machine learning model. But as you can see, in comparison, the size of that is much, much smaller. So the advantage of what we talk about, small and tiny machine learning model, what are they? Why we need to promote and ask the industry to consider in using it? Well, there's many reasons. Key reasons is number one, enable on-device machine learning at the edge, right? You can run on those small devices, and also you can get a high performance because the machine learning acceleration is happen right on the device. It's a local machine learning acceleration because now we have hardware to support it. And it's better privacy because in many applications that the data consumers has concern whether the privacy is being protected. Now, if you have machine learning run on the edge, the data is stay right on the device when required. So there's no data being sent to the cloud. It's much better privacy. And because of the local data, right, it's right or accessible right on the device. So for IoT devices, you do need to access the sensor data on the device. It's not practical try to get data from the cloud when IoT devices, let's say, do not even have a good connection to internet. In many cases, edge devices are not connecting to internet. So when the data is locally available, you can enable the device to do machine learning right on the device. So that's also an advantage. And work offline, right? It does not require internet connection. So again, as IoT devices, edge devices, many don't have internet connection. And so this enable the user cases to work offline. It's really huge. And it's more power efficient, right? Because as I said, it's a smaller form factor. We have hardware supporting a much less power consumption. If you need a device constantly running, if it can be supported by a battery power, solar power, you have a lot more flexibility to design and deploy these systems, right? And then lastly, this really creates endless opportunities for many, many innovations for Internet of Things, right? So because this small or tiny machine learning model boosts the intelligence of many countless of devices out there, which can help improve our lives, make our work job more efficient. So these are the advantages of a tiny machine learning and the technology now supporting all these, which makes the industry have opportunities to continue innovate on top of those. So we need a platform, right, to do a couple of things. To number one, enable those on-device machine learning. Needs to be at the edge, as small as possible, may not necessarily connect to the internet, and need to support a very small or even tiny machine learning models. So with that, let me introduce very quickly Coral from Google. This is a platform to enable all of these. So Coral is a platform for edge AI machine learning. And here you can see pictures of a variety of devices we make and sell to the industry. There's a developer board on the left. There's other plugin modules. It is a platform developing AI applications at the edge. With its a very unique on-the-machine learning acceleration feature because it integrates a chip from Google called Edge TPU. It has a 4 trillion operations per second machine learning inferencing performance. So it's very, very fast. In the picture, as you can see, this tiny little black square, this is the Edge TPU on this device. So 4 trillion operations per second, that means 4 million operations per second. That is very high speed performance. So now with that performance, we'll be able to run machine learning model right on these devices. Anyway, this is a family of products. More than just hardware, we also produce the operating system, machine learning models, and other software tools to enable all the users, our business partners, our customers around the world to use them to make products and making solutions. And it's very easy and fast to prototype and develop and deploy. The software we support is the Mandel Linux. It's a part of the version of the Debian Linux. And of course, all these products support TensorFlow Lite. We released this first on dev board on the left, as you can see, starting in 2019. So it's about a little over 3 years now. And so TensorFlow Lite is the baseline machine learning model supported on those. And so what can Coral do? Here's a couple of quick examples. This one, as you can see, with a smart camera, object detection and classification is one of the most common usage. It'd be able to detect even say moving traffic. As you can see in the video, on the left-hand side lower bottom, you can see this says how many frames per second. So 70 frames per second, that's a very fast speed with that little hardware. It'd be able to track cars. The percentage number you see in the little bounding box is what we call so-called confidence score. How confident the machine learning model identify or detect a object and think what it is. For example, if you see 50%, this machine learning model thinks it is 50% confident, think that is a car being detected. But because this is live video and in a traffic situation, car continues moving, it is able to continuously do this machine learning inferencing and detection on a continued video stream. So it is a very powerful machine learning power on that device. The other application is the so-called classification. Here you can see it captures objects moving as well, very fast speed at about 40 some frames per second. But in addition to car, actually, if you look closely, it actually identifies more than just the car, but for example, the traffic light, the pedestrian, and so on. So the classification models be able to tell all kinds of different objects. We have released about 40 some machine learning models, be able to detect all kinds of objects, banana, orange, fruits, vegetables, animals, and all kinds of objects. So these are the detection and the classification are the two most popular machine learning models on IoT devices that the industry has been using, developing solutions, and deployed so far. But in addition to that, we have some other machine learning model we have developed and supported. For example, this is a so-called body pics machine learning model. It will be able to observing, tracking people in public without showing their face, right? As you can see. It only shows the heat map of people moving in a scene. So now we can detect how many people in a scene, but not showing them who they are. So this is a very good so-called privacy preserving methodology to do people tracking, especially in public spaces, so that privacy preserving is very important. The other machine learning model we also have relates to preserving privacy is, for example, track people's movement. This is so-called the POSNet model that Coral supports it. As you can see, it tracks the people's movement, for example, where the head turns, but not showing their face. So in case you need to track people's body shape without showing the face, this is another model you could use. Also, we have the POSNet be able to do analyzing on the body gesture. For example, this you can see there's a lines and a dot links a human's arm and the body, but not really showing their face, right? The data being recorded, analyzed on, it was just the dots and the lines. So this allows the machine or IoT devices to be able to analyze how people moves their gesture without actually capturing their face, but only capturing the lines and the dots relates to their body. Similarly, we also have this dots and the lines, if you will, around the faces, but not neither recording the facial detail, but by analyzing the dots and the lines of the facial, we'll be able to tell the facial gesture, the facial expression, and so on. So these are also privacy preserving applications. So these are just a few examples, and the potential is huge, right? We can develop many applications using this for consumer electronics, home appliances. We have customers around the world doing that. And one of the largest applications so far among our thousands of customers are using machine learning model on the device using Coral to do warehouse management, assembly line packing, as well as manufacturing, industrial robots, consumer robots. These are the areas that the on-device machine learning model is being used widely. Automotive is another area, and healthcare, medical devices. Analyzing the imaging is also one of widely used use cases among the on-device learning. And of course, there's public kiosks, public service you can do. And lastly, in education area and the scientific research. So for example, we've been talking to Fermilab in Chicago. They're doing the particle smashing machine research. They are deploying Coral and to do scientific research. We have companies in the space industry even doing science research using Coral devices. And we're using one of the modules and with European Space Agency and using Coral on the International Space Station. So the industry usage is very wide, and the machine learning using object detection, classification, as well as audio processing with the model we supplied, has been deployed in these fields. So any, among today's audience, if you're working in any one of these fields, there's a great potential to using on-device machine learning with Coral. So now let's talk about the tiny part of the machine learning support. Let me introduce our latest product called the Coral Dev Board Micro. It is a tiny, small device, small enough to easily install everywhere. It uses very little power, and as I said, it supports battery or even solar power. Or you can even use power just based on the network cable, Ethernet cable connects to the device. Be able to continue monitoring and changing what happens in a video scene the camera sees. And use a very tiny, lightweight machine learning model. That is the new TensorFlow Micro model. This is the first device that is currently support TensorFlow Micro in the marketplace. And now we just released it. I made an announcement in Google I/O this year. The product we are manufacturing right this moment as we speak. And the product will be available at the end of or middle of next month among the retailers that our partners will start selling them. And it can perform a high power machine learning model as well. So it will be able to run both TensorFlow Micro as well as TensorFlow Lite model, two machine learning models running in tandem on the device. So here, let me do a quick demo on a video which I presented to Google I/O. This is like I think a 5 minutes video showing you this dual mode machine learning model on device, in action. It actually runs one of the models is the machine learning model TensorFlow Micro, the tiny device, tiny machine learning model right on the device. So here, let me run this video. It's about a few minutes, and I'll let you watch.
Here is a new product from Coral. It is a microcontroller called Coral Dev Board Micro. First of all, it's very small in size, and you can tell how tiny it is by its relatively size compared to my hand. Second, it consumes very little power, and it can be powered by any USB power supply. Here, I attach it to a small camera tripod and simply power it up through a USB-C cable and connect to a USB port on my laptop. With the Coral Dev Board Micro now powered up, I'm going to run an out-of-the-box experience program, or the so-called OOB or OB program, to demonstrate its capabilities. On my Linux laptop here, I have a command window open on the left side of the screen, where I'm going to start a OB program with this following command, which simply starts the OB Python program. Once I enter the command, you will see a new window pops up, and it shows a video of myself in the frame. This is a live video continuously being captured and updated by a tiny camera on the Dev Board Micro itself. In the command window, every few seconds, the OB program displays the frame rate of the video and the elapsed time between each update, where the program uses a machine learning model to detect the presence of a person in the video scene. Now I will change the camera direction to have it pointing upwards instead of at me, so that the video scene will no longer have me as a person inside. Notice that now the center green LED light on the board is turned off. This is a light that indicates whether the predefined object by the machine learning model, such as a person, is being detected or not. And if it detects a person in the scene, the LED will light up. Now I will change the camera to point at me again. And you will see that in the video, there are some dots and lines superimposed on my body. This is the result of another machine learning model, the POSNet model, running on the device, which generates the so-called body segmentation lines over a person's body. This feature of POSNet can be very useful for many applications and use cases to detect the presence of a person anonymously while preserving privacy. And the segmentation lines can be used to analyze the gesture of body movements in the scene. To see how the DevBot micro switches between the two machine learning models, you can open a separate console window and enter a screen command like this. Now let's see how the board operates in two different power modes. First, let's switch the camera so that there is no person being detected. And the screen console shows that the device is running in a person detection mode in the M4 main loop. This is a low power mode running a TensorFlow micro model, which consumes very little power, and it updates the detection every few seconds. Next, I will switch the camera to point at me again. And once the person detection model detects me, and you now see that the body segmentation lines appear on my body again. The screen console shows that after the person is detected, the device switches to a high power mode with the M7 core wakes up. And it switches to the second machine learning model, the TensorFlow-Lite POSNet model, generating the body segmentation lines and superimposing them on the body image in the video. It is very cool that this tiny device is able to run two different machine learning models based on what it sees through its onboard camera.
Okay, so this is a little bit of demo of the new TensorFlow micro running on the Coral device. So what you just saw here, it is a dual mode operation and two machine learning models running in tandem together. First, after the power up, right, the DevBot micro starts and it automatically turn on the so-called OOB program. And on the device itself, it has a low power M4 core and it runs the TensorFlow micro model. This is the tiny machine learning model. It's running and continuously monitoring, see if there's a people being detected. And when it sees image that has a people being detected, it wakes up a different core. It's the so-called M7 core. The M7 core starts a full power mode. It triggers the TensorFlow-Lite model POSNet, which it will able to put the body segmentation lines and the dots using the POSNet on the superimposed on the image of the person. And then if the person is gone, for example, it will continue to switch back into the M4 core mode and then use the TensorFlow micro mode in a continuous loop, try to detect people, right? Or detect the presence of the person in the video. So this is what happened you just saw in the demo. It demonstrated the capability of this little tiny device, be able to, number one, support the tiny machine learning model of the TensorFlow-Lite micro, and it also be able to run a little bit more powerful machine learning model POSNet using the edge TPU with TensorFlow-Lite model. That is whenever a person is detected. So quickly, let me introduce this product in a bit more detail. So this is a new DevBot from our product line. It is a microcontroller class device with low power support. It supports the dual mode as we just saw. It uses a MXRT1176, so-called crossover microcontroller unit. It has a 2-core inside, so-called supporting the ARM M4 and M7 cores. And the key part of that, this is the first device in the industry on the market that supports the new lightweight TensorFlow-Lite micro model. That is really the tiny machine learning model. And it will be able to do detection, and it can be able to run a continuous mode with very light power support. And then the M7 core can be used to be triggered if the low power mode in M4 detects something, and it triggers a TFLite model to run other machine learning models such as POSNet. And it is very small, right? As I said, you can see in the image, it's about 65 millimeter per 30 millimeter size, tiny bit, and support a battery. It runs a free RTOS machine operating system on the device, and it is compatible with Arduino's SDK. So in terms of development, it's very easy to use. It supports low-power TFLite micro model, and it has an onboard camera right built into it. So you can deploy this in the field anywhere to support the imaging recognition, do classification, do detection. It also has a microphone, so you can do audio machine learning model as well. The camera, onboard camera, is about 324 pixel size, and also has about 110 degree of field of view. So it's very flexible with such a wide angle camera right on the device. Okay, so we talk about the micro devices with the tiny machine learning model. Let me switch to the second part of the content, which is the on-device learning. We want to enable machine learning model to learn something on the device without using the cloud, what we call learning on the fly. And that is possible as well with Coral. So Coral platform provides this on-device learning capabilities, what we call using a transfer learning. This is one of the research areas that there are machine learning models available, the methodology available to do learning on the fly very quickly without retraining on the small devices, because on small devices, due to the memory size, it's not possible to do training. So we have developed this tutorial as well as the software to enable industry use. It's called the Teachable Machine. On the left, you can see it is a picture of it. I'm going to show a quick demo as well. But basically, it will be able to teach this machine to recognize certain shape of the certain shape, color, size, whatever, of an object, and it will see it by the camera, and then it will remember, it will recognize it. So basically, you enable machine to learn on the fly using the machine learning model technology right on the device. Now, because at Coral, we already supporting all these models, and we will be able to do that. One of the applications on the right-hand side of the picture you can see, somebody developed this sample learning machine called the sorting machine, be able to recognize all the different sizes and the colors of cereal. So, you can get a box of cereal and you put it into this sorting machine. It will be able to sort the cereal based on their color once the camera sees them. And both of these are available on our website. You can download these tutorials and build it yourself. So with that, let me talk about quickly the idea of this transfer learning. So in a machine learning model, right, you have this neural network, which is millions of what we call neurons in this neural network, represent different things, aspects of the object needs to be decided and learned. So the typical neural network is, again, millions of layers of objects. It takes a long time to train. It's almost impossible to train them on a device if you want to retrain the entire neural network on device with millions of these different vectors, right? So the transfer learning idea is, instead of retrain the entire model, you only retrain the top layer vector. In other words, the process of this transfer learning is you disconnect this entire, disconnect the top layer of the vector from this entire model, and then replace the top vector layer with the things the machine learning just learned. So, for example, you can have the machine learning model being trained with images seen by the camera, and only change the top layer for certain size, shape, or whatever the object you want machine learning to learn. But all the layers below, on the left side of this orange color, they represent different neuron aspects of the vector representation, right? It could be object size, shape, these being trained before still can be used. But for a specific object size and shape, we only need to replace them on the top layer at the right. And once that is done, you can have the machine learning be able to, the model be able to recognize the object right there without retrain the entire model. And this is the technology enable learning on the fly, right on the device possible. So here's a quick demo. I did this at the 2019 Google I/O presentation. Let me run this a few minutes demo as I was showing to the audience. As you can see, this so-called teachable machine what it does. Okay, so let me, oops.
So with that, let me do another demo for you. It is called the Teachable Machine. We are going to publish this as open source for you to do the same in the near future. But basically what you see here, I'm going to show you, I'm going to make a machine to remember things. So the videographer, we need to have an image of this. So on the desk here, what you see, it was built based on this USB with a Raspberry Pi, right? So more than dev board, you could use a Raspberry Pi to build an application. So here with this little bit of demo, and it has a camera points up, and I have some different objects, okay? So if I hit a button to take, so every time I hit a button and take an image, let's say of this hamburger, it remembers several images of this hamburger. Now, if I take a different object and take a different group of photos of the second object, it remembers the images. And I'm going to take ice cream on the green button. And lastly, maybe I'll take this donut with the red button. So what happens in the background here, the program runs doing a transfer learning, take an existing object classification model, but replace the last layer with the image that I just taken. Okay, now watch this. If I put this hamburger back, the yellow light turns on. It remembers. If I put the ice cream, the green light turns on. I hope you can see on the video, yes. And if I take this donut, the blue light turns on, right? Now, more than that, a moment ago, I trained with this green ice cream, right? The green light. If I put a yellow ice cream, it remembers too. Because it's a machine learning model, more than just the color, and also identify the shape. Because this shape and this shape is different, the model is smart enough to know the difference between the objects. So again, this is one of the examples you could use to building things with the capability of classification right on the device without internet, and build even with a small USB key like that, right? Very powerful stuff. Thank you. Okay.
Please, Bill, I think you're running out of time. Can you kindly wrap up?
Yeah. So this is that's pretty much done. So I only have one page summary. So again, you have seen machine learning with Coral on device. So adopting Coral for your on-device machine learning innovations. Coral Dev Board, Coral Dev Board Mini, Coral Dev Board Micro. These are the things very easy for prototyping. We have a USB and micro PCIe and M.2 modules. You can plug into existing host, your computers, laptops, or whatever to do that. And then the new Dev Board Micro opens up the possibility to running on tiny devices with very little power. And on-device learning with Coral devices transfer learning enable you to have the machine running right on the fly. And so for more details, we have a website with all the products, documentation, machine learning models for you to download. It's at coral.ai, very easy to remember. So with that, that's my presentation. Thank you all very much. And please, I guess, if anybody have questions, I have an email here. You can contact me anytime if you have further questions regarding to our product. Okay, that's it. Thank you again.
Thanks so much, Bill. It was a great presentation. You touched different aspects from the Coral product and demonstration. The demonstration was just great. Since you took more than 30 minutes, let me just select one question from the attendees, and I kindly ask you to follow up with all the others staying with us.
Yes.
There is one specific question on the transfer learning. Is that happening on the M7 or on the M4, or where?
The example I was showing, the Teachable Machine, that was built. I don't have the product with me. I mean, the demo is myself with me. That's why I have to show the video. But it is built with our USB module, which is a tiny module, along with a Raspberry Pi. And so Teachable Machine can be running on all the Coral devices. I have not tested with the micro device, which in fact, I have this with me, as you can see. This is the microcontroller. But I have not tested or built the demo with the microcontroller. But all the other Coral products, such as the dev board, the USB module, or even plugin module with any host, is all possible. It's all available. My personal suspicion is it probably needs a powerful CPU for supporting business logic, meaning the application program itself running. So with that, you probably need a bit more powerful machine, and the single board computer, such as the dev board or a Raspberry Pi, for example, definitely is good enough to enable that.
Thanks so much, Bill, for your time. Your availability was much appreciated. As a sign of interest about the Coral product, there are 15 outstanding questions. I strongly suggest you to address one by one, because the people is very eager to listen from you and are specific to the product. And therefore, thanks so much. And let me switch to the next presenter. Thank you, Bill. That forum was possible thanks to the tinyML Foundation support and all the support from the strategic customer, which are helping a lot in providing resources to make sure that this forum and other events and other interesting events will happen in the future. So just to thanks also and list the executive strategic partners: ARM, Edge Impulse, Qualcomm Research, Sentient, and the Platinum strategic partners: TFLite, Clickattack, Reality AI, Renesas, Sony Semiconductor. The Gold strategic partners: Analog Devices, PhotoHub, Microsoft, NXP, Seed Studio, Sensimil, ST Microelectronics, Synaptics, ScienceSense, and all the silver strategic partners. Thanks again to stay with us yesterday and today, and I hope it was a valuable experience. Thanks, and see you soon. Bye.